Hello, this video is to show a project about graph embedding. The main task of this project is to use holographic embeddings to learn compositional vector space representations of a given knowledge graph. This project is modified from a previous work. Here is a reference. The inputs of this project are tuples that contain subjects, relations, and objects in the knowledge graph, and the outputs are embeddings of all entities and relations in the knowledge graph. The main approach is to use holographic models of associative memory, in that it employs circular correlation to create compositional representations. Here is a model to train and test data, which means giving all embeddings in the knowledge graph the big theta. The probability of the statement that the relation between subject S and object O is P is true should be maximized to represent the entities and relations distinctly. The project used pairwise rank loss to update the model. To ensure the model can learn the entire knowledge graph, it generates negative instances to train. In the formula, D sub plus denotes the positive instances in the knowledge graph, and D sub minus denotes the non-existing negative instances. Here are the evaluation datasets I used in the project. Walnut, Freebase, Yago, and Wikidata are datasets providing rich relation and entity information. The evaluation methods used are constant similarity, MR, MRR, and HISAT. HISAT N reports the ratio in which the correct prediction occurs within the first N results. The authors of the paper only used MRR and HISAT to evaluate it. I also compare the effects brought by the number of negative instances. Surprisingly, the more negative instances cannot bring better performance. The best performance comes when the ratio between the positive and negative instances is 1. Let's start the demo. Firstly, the project will import the required packages. Then, it loads data from the defined file path. The function with dataset will generate the data for training, validation, and testing. Since the trainer will only use IDs to represent the entities and relations, the mapping relations will be stored in entities and relations dictionaries. Here are some settings of the project. To save time, this project will only have 5 epochs to train the model, and 1 negative instance will be generated for each positive instance. The dimension of the embeddings will be 300. In this demo, I generate embeddings for Walnut dataset. In the learn embeddings function, the evaluator, model, and trainer will be built, and the model will be trained and generate embeddings. The epoch, execution time, and number of violations will be printed during training. To save time, I will speed up here. The generated embeddings will be saved in a predefined path. One example of the generated embedding will be printed here. The vector's dimension is 300. The model will also be saved. Finally, the generated embeddings will be evaluated with the predictions, given a pair of subject and relation, or a pair of relation and object. The model will generate the mixed object or subject embeddings and compare the generated embeddings with all embeddings. The one that is most similar to the generated one will be selected as the result as a prediction, and it will be compared with the correct one. Here I use constant similarity to measure the similarity between the predicted embeddings and the correct embeddings. The mean rank and HISAT to measure the accuracy of the predictions, while the authors used MRR to measure it. Here are the evaluation results, including constant similarity, MR, and HISAT. It is the end of the demo. Thank you very much.